how close is our society to the future that we see depicted in Nichols' 1997 film Gattaca? And it's about the challenges faced by Ethan Hawke's character, Vincent, who lives in this dystopian world where genetic engineering determines one's path in life. Genetic engineering in Gattaca refers to manipulating human DNA to produce designer babies with desired traits. In the opening of the film, on-screen text appears, as seen, that says, "in the not-too-distant future," which suggests that Gattaca is set in a time period that is not so different from our current society, and it isn't so far-fetched. This raises the question then, almost 27 years after the film's release, how close are we to the future society seen in Gattaca? Welcome to Hannah's Science in the Cinema series, where we will explore this question. And there are two main things to consider when thinking about how close we are to a Gattaca future. The first thing to consider is how close is our current technology to the technology portrayed in Gattaca. Gattaca depicts an advanced genome editing technology where many traits can be edited and engineered before birth. Here is pictured Vincent being born. He wasn't genetically edited. Additionally, Gattaca portrays advanced genetic testing, which can use various human samples, including blood, as pictured, where they use finger prick blood tests to test for DNA, and also urine, skin cells, hair, and they can all be used to fully sequence an individual's DNA. The second thing to consider is, how do today's societal values, particularly about genetic engineering, compare to those in the dystopian world of Gattaca? In Gattaca, society discriminates against those who had a natural birth and don't have genetically enhanced traits. And as you can see here, Vincent, who was not genetically engineered, he is seen as invalid and is discriminated as such. Genetic enhancements for non-therapeutic reasons unrelated to diseases are normalized. Things like gender, hair color and eye color, and athletic ability. Even someone who has 6 fingers so he can play the piano. All of these things are encouraged in the world of Gattaca. And how do our societal values at the moment match up with that? A combination of the technology we have available and the societal values we hold produce the dystopian society depicted in Gattaca. Stay tuned for the rest of this series, where we find out whether a society like Gattaca is in the not too distant future, as the movie predicts. Now we will discuss what technology do we now have and how does it work, and how is it close to what is depicted in Gattaca. In an early scene in the Gattaca movie, Anton's and Vincent's parents are discussing with the geneticist the traits that they want their newborn son to have. The geneticist says, "You've already specified blue eyes, dark hair, and fair skin. Have taken the liberty of eradicating any potentially prejudicial conditions. Premature baldness, myopia, alcoholism, and addictive susceptibility, propensity for violence, and obesity." This shows that not only are therapeutic, as in curing of diseases, genetic engineering is used, it's also used for non-therapeutic enhancements, such as specifying the eye color, the hair color, and physical traits. Gene therapy is when parts of your DNA sequence are changed to repair, replace, or inactivate mutated genes that are linked to genetic diseases. Gene therapy can either be somatic gene therapy or germline gene therapy. Somatic gene therapy means that genes are altered that don't get passed on to the next generation. Germline therapy alters reproductive cells such as sperm, eggs, or embryos, and these gene alterations are heritable by future generations. As you can see, before the embryo turns into a human, gene editing is done on it before that embryo becomes a fully formed human being. Whereas the somatic gene therapy is done within the cells of a human that is already fully formed. They are not done on any kind of reproductive cells such as sperms or eggs or embryos in somatic gene editing. Typically, gene therapy is used to treat diseases, but similar technology that is used for this could also be used to make enhancements for non-therapeutic purposes. CRISPR-Cas9 technology is the most precise gene editing technology to date. It is comprised of 2 elements: the guide RNA, known as sgRNA, and the protein, which is the part that cuts the DNA. It works. This sgRNA finds the part of the DNA sequence that matches up with its RNA, since RNA and DNA go together. Then the Cas9 protein, as it is a nuclease, is able to cut that part of the DNA, and so it cuts the specific part of the DNA, and now that will trigger the reparation of that DNA. There are two main ways that DNA repair can happen. If scientists provide a donor DNA template, then the DNA has clear instructions for how it repairs itself, and it can repair itself without any mistakes. This method is called homology-directed repair, or HDR for short. If no DNA template is provided, then the DNA repairs itself, often with errors, and that can disrupt the gene. This method is called non-homologous end joining, or NEHJ for short. Both of these methods are viable and useful for genetically editing different ways. Despite CRISPR-Cas9 technology being much more precise than previous gene editing technologies, for sure more accurate than what was around during Gattaca's release, as CRISPR-Cas9 was only invented in 2012. Despite how far we have come, there is still a significant risk that we would make off-target changes to DNA, which could result in unwanted health issues. As you can understand now, the CRISPR-Cas9 molecule searches for the part of the DNA it wants to edit, but it can make mistakes and target the wrong part of the DNA and edit that instead, and that can cause unintended health issues. If these off-target changes to DNA, which are unwanted, were done in human germline gene editing, then these unintended changes can be passed on to all the future generations, and this could change the trajectory of human evolution. For this very reason, human germline editing is illegal in Australia and many other countries, and is prohibited in many others, and is highly controversial. Currently, gene editing technology CRISPR-Cas9 is being used to treat a variety of diseases, including HIV and sickle cell disease and forms of cancer. Despite controversies, the world's first genetically edited babies, which are germline editing, so changes genetically editing these babies before they were born, would affect the rest of the future generations. The first genetically edited babies were born in 2018 in China, and Dr. He Jiankui, who's pictured above, performed the gene editing in 2018. And they were twins, and their genes were edited to protect them from HIV, as the father had HIV. Consequently, Dr. He Jiankui was fired from his university, was sentenced to 3 years in jail, and was condemned for his actions. So far, this is the closest that we have ever gotten to a Gattaca future, and there is not much information that we can find out about the twins and whether they have been successfully protected from HIV, or if they have had any other unwanted side effects of this gene editing. In terms of non-therapeutic enhancements, gene editing to increase the ability to build muscle mass has already been done on mice and pigs. It was found that for rats, gene editing increased muscle, reduced fat, and even reduced the severity of osteoarthritis, which is a result of obesity. As you can see, that this is a non-therapeutic enhancement. It increases muscle mass, but it does have some therapeutic application, as it decreases the disease of osteoarthritis. So the line between enhancements and treating diseases is sometimes blurred. Other than gene editing, there is also other reproductive technologies that can alter the course of the genetics of your children. So with IVF, there is a technology called PGD, and with it you can select the gender of your newborn child with almost 100% accuracy. And this may seem superficial, but there are also applications of this, as some diseases are more likely to be inherited by males or females depending on what the disease is. So if you're able to pick the gender of your child, then your child may not have that heritable disease. So overall, it doesn't seem like we're very far off from the technology that's depicted in Gattaca. Sure, there are not not all traits can be genetically edited, such as eye color and hair color, but with research, we are not far off from this happening. The next step would be for society's attitudes to change, and then following society's attitudes towards genetic editing changing, then scientists would put more and more research into genetic editing and make the things that are in Gattaca a reality. So what are society's attitudes towards genetic engineering, and is it close to that of the people that are depicted in Gattaca? Currently, society's attitudes towards genetic engineering are pretty positive towards gene therapy that treats diseases, but negative toward non-therapeutic genetic enhancement. As you can see in here, this is for genetic engineering that's done on adults, and most people seem to agree that it's good for those who experience diseases, but much less people agree that it's good for genetic enhancement, which doesn't treat diseases. Additionally, a 2021 study conducted in the US showed that most people are in favor of genetic editing to treat serious diseases and conditions that a person has currently, so that is not going to be passed on to the next generation. And most people are against making a baby more physically attractive, which is something that is seen in Gattaca. As we can see, society's views towards genetic engineering aren't very positive when it comes to genetic enhancement. So I don't think that in the near future, people will become obsessed with genetically enhancing themselves, as well as discriminating against those who aren't genetically enhanced. But I think it's worth noting that enhancements are done today, and people are discriminated for their looks all the time, and people go out there and alter their looks with cosmetically. So I don't think that the discrimination aspect of Gattaca is far from our society today at all. But I do think that our society's attitudes towards genetic editing are a little bit conservative, so I don't think that a future like Gattaca will be happening soon. But it was really interesting to investigate the technology and the current views that people have to see just how close are we to a society where that your genetics determines your future in this project. Thanks so much for watching. Bye bye.